Hello, physical scientists. Ms. Getz here today. Today, we're going to learn some stuff about the universe. We're going to try to understand how big it is. We're going to try to learn what the different things are that are inside of the universe that we can see. And how is it that astronomers know all of this anyway? So, we'll go ahead and start off with our Earth orbiting the sun in the solar system. So our Earth is that lovely blue planet, and actually it's pretty tiny compared to those gaseous giant planets you've heard of like Jupiter and Saturn that are made up of entirely gas. That a few of them have a solid core, some of them we're not so sure, but they're mostly made of gas, and they're very, very large compared to these rocky inner planets in our solar system like Mercury, Venus, Earth, and Mars. All of the planets orbit in circles, with the exception of this dwarf planet you've heard of called Pluto, which is really a very elliptical orbit. That means it's like a squished circle. And you notice that it's like off the plane of all the other planets. And those are some of the reasons that Pluto is now a dwarf planet instead of a real planet. But an important thing to kind of recognize with the solar system is that it's really big. So this picture is not to scale by distance, but it is to scale by size, so that you can get an idea of how tiny these inner planets are. So here's Earth, you can barely see it, and the sun, very, very large in comparison. And so our solar system is pretty big. And there's some other stuff in our solar system. There's comets, which are frozen gas and dust, kind of like a snowball. And comets orbit in the Oort cloud, and they come in towards the inner solar system. They have these big elliptical orbits, squished circles again, and they get tails when they come in towards the sun because they heat up, and their dust and gas and stuff blows off of them from the sun's heat and radiation, and causes them to have these interesting tails. They actually have two different tails. Then we have asteroids. You've probably heard of those as well, and they're just rocks. And the asteroid belt is from rocks that astronomers think were started to form a planet and failed to form a planet when the solar system was forming. And they're pretty boring. But I will highly recommend comets as an astronomical object. If you ever get a chance to see a comet, it's super cool. So this is Comet Neowise, which we could see this summer actually here on Earth. It didn't look quite this grand here in the Northern Hemisphere, but it did look pretty cool. And you might have heard of Halley's Comet or Halley's Comet, and that will be coming back to the Earth in 2061, and you can check it out then. It's a pretty big comet, and so it looks really cool. Then we'll zoom out a little bit. So the nearest star to us is Proxima Centauri. It's part of the Alpha Centauri system, and it's 2.4 light years away. 4.24 light years away. And that is a lot of miles. So it's, let's see, here's the millions, here's the billions. It's 24 trillion miles away. That's pretty darn far away. But it's just one of many stars that are pretty close to us. There's a lot of stars near us. So Proxima Centauri and Alpha Centauri are right here. Then there's other stars that are pretty close to us as well. And our solar system and all of those stars are part of the Milky Way galaxy. So this is what the Milky Way galaxy looks like here on Earth. If you're ever able to go someplace really, really dark and do some stargazing, you can see the Milky Way galaxy. It might not look quite this grand. Photographs are better at getting light than our eyeballs are. But you can see the Milky Way galaxy, and you can see the clouds of gas and dust in it that block out the light from the stars, and you can also see the light from all the stars in it. It's really awesome. And so this one is a real picture of the Milky Way galaxy. This one is a drawing of the Milky Way galaxy. And all of the stars that you can see at night are actually in a really small area of the Milky Way galaxy. They're right around us here. We live here in the Milky Way galaxy, and astronomers have a pretty good idea of what the Milky Way galaxy looks like based on what we can observe from it and how far away those different stars are that we can observe with telescopes. So the Milky Way galaxy has a lot of stars. Again, you can only see some of them at night. Most of them are blocked out by the other gas and dust that's around us that makes it hard to see them. So the Milky Way has 200 billion stars in it. And I'd like you to imagine that if a star was like a rainbow sprinkle, delicious on cookies, rainbow sprinkle. What kind of car would you need to fill up with rainbow sprinkles to have 200 billion sprinkles? What do you think? Would it fit in your normal four-door car? Would you need more of like a bus or a truck? Maybe a big shipping truck? Well, actually, you'd need 15 school buses. 15 school buses full of rainbow sprinkles would be 200 billion sprinkles. And that's the number of stars there are in our Milky Way galaxy. But our Milky Way galaxy actually is part of a local selection of galaxies called, creatively, the Local Group. And so there's the Andromeda galaxy, the Triangulum galaxy. There's some little baby galaxies hanging out around us too. And they're pretty far away. So the Andromeda galaxy is about 2 million light years away from us. And if the Milky Way galaxy were about the same size as a DVD or a CD, the nearest galaxy, the Andromeda galaxy to us, would be 8 feet away. So pretty far away. So the universe is actually full of a lot of empty space. Just a lot of empty space. There's areas of clustered stuff like our solar system, and then there's a lot of empty space between us and the next star. Similarly, there's this clustered stuff in a galaxy. Then there's going to be a lot of empty space between our galaxy and the next closest galaxy, the Andromeda galaxy. And the universe is also really, really old. So the universe itself is 13.8 billion years old. That's pretty darn old. And it has 100 to 200 billion galaxies, and each of those have billions, hundreds of billions of stars inside of them. So the universe is very, very old, and it's very, very, very large. You've probably heard a little bit about the Big Bang back in middle school, and that's the birth, the start of the universe. And we can't actually see back to the very beginning of the universe in the Big Bang, but we can see that first light, that baby picture of the cosmic microwave background. Then there was a long period where the universe was just kind of hot, kind of soupy, not a lot going on, and they started eventually forming stars. The universe started forming stars and galaxies. And those galaxies interacted, and those stars lived and died. And eventually we get to the present day. The universe is pretty big, and it's got a whole lot going on in it. And galaxies inside of our universe come in many different shapes and sizes. They can be elliptical galaxies, which I'll admit aren't that pretty. They can be spiral galaxies, which are very cool looking. And they can be irregular galaxies, which just are a little bit funky, a little bit, unsure what's going on. And galaxies even sometimes collide. So this is the Whirlpool galaxy, and it is actually mid-collision. So you see this spiral galaxy and then this funny lump. This is another galaxy that is running into that galaxy. Astronomers study these collisions with computers to try to understand what happens, and they can take lots of cool forms. Look at all of these cool pictures. So these are all galaxies, real pictures of galaxies that are interacting, that are colliding with each other. And our galaxy will actually eventually collide with the Andromeda galaxy, our nearest neighbor. And astronomers observe galaxies in different wavelengths of light to understand different things about them, what they're made of, where they're going, what they were like in the past. And so they use those different types of light to understand them. Inside of galaxies, like our own galaxy, there are stars and nebulae. Nebulae is the plural of nebula, and that's clouds of gas and dust that are stuck together with gravity. And they're the beginning and end of a star life. So this is the Eagle Nebula and the Orion Nebula. Those are the beginnings of stars' lives. This is the Veil Nebula and the Ring Nebula and the Crab Nebula. Those are the ends of stars' lives. And they're all hot gas and dust. And they look really cool. There are lots of different types of stars. We're starting to study the exoplanets, the planets around other stars, and we're pretty sure that most stars have planets around them. Lots of stars are binary star systems with two stars orbiting each other, and even those binary systems can have planets around them. Stars are clustered together oftentimes with gravity holding them together. This is called the Pleiades. You can actually see it in the night sky right now. Um, and this is an open cluster. It's inside of our galaxy. Then there's these things called globular clusters that kind of hang out around the outsides of galaxy, and they are really cool and really pretty and have thousands of stars collected together inside them. So you might be wondering, how is it astronomers know all of this? Well, the fact is that humans have been observing the night sky for thousands and thousands of years to do navigation and find where north is. You've maybe seen the Big Dipper before, and that can help you find the North Star from these pointer stars. And to really keep track of what's happening, here's Halley's Comet way back in, I used to know the year, but I don't remember it anymore. That's okay. Way back in medieval Europe. The ancient Egyptians used stars to observe what was happening in the stars, to keep track of them, and to predict the seasons. And the ancient Islamic world did a lot of early astronomy. They were the most scientific early astronomers because they really wanted to use stars for navigation purposes to know where Mecca was on Earth. And many cultures have used the stars to orient our buildings and make them line up with the equinox, with the sun, or with the stars in different ways. So astronomy has been something humans have always been practicing. But astronomy got a little bit more exciting, maybe a little bit, when astronomers started using telescopes. You've probably heard of Galileo Galilei, and he pointed a telescope towards the stars, towards Saturn and Venus and Jupiter, and noticed these other planets. Some of them have moons, like our own planet does. We didn't realize that. And some of them go through phases, like Venus, which is what allowed him to really prove that the Earth goes around the sun, not the other way around. And there's different types of telescopes, refracting versus reflecting. Refracting are like glasses. Reflecting are like glasses plus mirrors, essentially. And originally, astronomers just observed with their eyes. They made drawings. Photography came along and allowed astronomers to do some other things. Spectrometers came along, allowed astronomers to do some other things. And really, technological advances allowed astronomers to do many cool things. And so now, today, we have many different types of telescopes. There are telescopes in space, like the Hubble Space Telescope. Not all, but most of the pictures we've been looking at today, including the background picture, which is all galaxies actually, is taken with the Hubble Space Telescope. This is the James T. Webb Space Telescope. It's still here on Earth. It's still being finished, but it's going to be very cool when it launches. It actually is a telescope that folds up and then unfolds when it gets to space. We have this very large telescope. That's actually its name. Pretty boring, right? But the very large telescopes use lasers to know what's in the atmosphere and modify how they're looking at the stars to have the best focused light possible so that the Earth's atmosphere doesn't make the picture crummy. Then there's this telescope that probably doesn't even look like a telescope to you. It's called the Very Large Array, and it's a radio telescope. And so it's a bunch of radio dishes. These are actually very large radio dishes, and they can slide around to look at the radio signals coming from around the Earth. And this is Harding's telescope. So Harding has a telescope from the 1970s, and it does still work, and Harding's Astronomy Club uses it when we're in normal school pretty often. So astronomers examine the light coming from all of these different objects to learn what they're made of and how far away they are. This is the light spectrum that comes from different types of stars, and you'll be learning more about that in your next activity. So you'll notice in your next activity that stars actually come in different forms, different colors, different sizes, and you are going to be investigating some of these stars to learn about some of the patterns that astronomers have used to explore and understand our universe. So good luck, do your best, and keep exploring about astronomy. It's a really cool topic, and we're really excited to be doing it in physical science.